In this video, we're going to continue topic 6.1 and 6.2, and we're going to talk about right rectangular approximations, or RRAM this time, is an abbreviation for that. I did miss something in the last example, though. If you'll notice, this here, again, there's gaps, so we would want to tell you if it's an overestimate or an underestimate, and because there's those gaps that's underneath the curve, it would be an underestimate. Okay, let's look at example 3. So this time it says that we want to do the area under the curve using subintervals. We want to use 5 subintervals from 0 to 5 of this function. So again, Delta Math is going to write it like this. And you just have to know to do the width of the subintervals, it would be 5 minus 0 divided by the number of subintervals they ask you for, which is 5. So again, in this case, we've kept it very simple, and the width of our subintervals is 1. So this time, though, I'm drawing my rectangles from the right, so I'm going to practice that. So I'm going to go up from the right, from the 5 first, and over and down. Up from the right till I hit the curve, over 1 and down. Up from the right till I hit the curve, over 1 and down. Up from the right till I hit the curve, over 1 and down. And up from the right till I hit the curve, and over 1 and down. Okay, you don't even really need to do the work to decide if this is an overestimate or an underestimate. Obviously, there's rectangles above the curve, so this one is going to have to be an overestimate. Okay, so I'm going to go ahead and do that table again. So I've got x and f of x. And this time, I don't really need the value for 0, but I want 1, 2, 3, 4, and 5 because I'm starting with this height on the right side. So 5 squared is 25, 4 squared is 16, 3 squared is 9, 2 squared is 4, and 1 squared is 1. It told me 5 subintervals, so for my RRAM, I'm going to set up for 5 spots. So 1, 2, 3, 4. Okay, so I've got 5 blanks, and I always like to start from the right side. So I'm going to use the table to help me. I'm going to use this height, and then I know the distance in between is 1, so 25 times 1. And again, that distance in between in Delta Math could be a decimal point. And then I've got 16 is the height, and my distance in between is 3. 9 is the height, distance in between is 1. 4 is the height, distance in between is 1. 1 is the height, distance in between is 0. Oops, sorry, is 1. It's still 1. Sorry, not 0. Okay, and then when I multiply that all out and I add that all up, I end up with 55 as my overestimate. Let's also look at example 4 really quickly. So this time I am going to start from the right side again. And notice I hit the function right there, so I go over 1, not very much height. I'm going to go up until I hit the function, and over 1, because again, it did tell me I had to divide it into 4 subintervals. I'm not going to do the fancy Delta Math notation this time. Go up 1 and over 1, or up till I hit the function, over 1, up till I hit the function, over 1. Notice there's gaps this time. The function was drawn a little differently, so this one would be an underestimate in the end. All right, so I'm going to do my little chart for my table here. So I've got x, f of x, and I am looking at, I know I've got the values. I don't need 0, but 1, 2, 3, and 4. So when I put 4 into here, 4 squared, think about this. It's negative 4 squared plus 16, meaning that the negative is outside of the squaring part. So that makes it 0. Then it would be 3 squared is 9, so negative 9 plus 16 would be 12. And then that doesn't seem right, does it? Negative 9 plus 16 would be 7, not 12. I read my numbers wrong. All right, I'm going to put in the 2. So negative, so before negative 4 plus 16, there's our 12. Put in the 1. 1 squared is 1, and negative 1 plus 16 would be 15. All right, I'm going to do my RRAM. And I'm going to go set up for, it said it wanted 4 subintervals. So 1, 2, 3, So there's 4 spaces. And again, I like starting from the right side. So if I'm going from the right, I start from the right. So my height is 0. My distance in between is going to be 1. My height is 7. My distance in between is going to be 1. My height is 12. My distance in between is going to be 1. My height is 15. My distance in between is going to be 1. When I add that up and multiply it all out, I end up with 34. So really quickly on overestimate and underestimate, if we're looking at this and we have, and I wouldn't memorize this, this is why we draw the pictures. So if we have a strictly increasing function and we are doing left rectangles on it, this would be an underestimate. But if we're doing right intervals on it, we're coming from this direction, it would be an overestimate. And again, I always just get it right from the picture. If we're doing strictly decreasing in a left function, then it is an overestimate. And if I'm doing strictly decreasing and coming at it with rectangles from the right, it is an underestimate.